Okay, welcome to the video for 5.7 Law of Sines. So we're going to use some trig to help us find some information about non-right triangles. But we're going to see that the reason we can do that is because there's right triangles within those triangles. So our first problem here says, find the area of the above triangle. And it's talking about the triangle that's shaded in as blue here. We're going to find the area of that. So we know that the formula for finding area is 1/2 times base times height. Okay, so 1/2 times, well, we have the base, is 150. But we don't have the height, right? So the height here is right here. We don't know what that is right now. But if you look, we do have a right triangle here and an angle that might help us find that height. So I'm going to put an X here. So now if I were to set up the trig equation, sine of 40 degrees equals opposite x over 100. I could find out what that height is right there. So to solve this, I would multiply both sides by 100. And I'm left with 100 times sine of 40. Now I'm not going to put this in my calculator quite yet, but this just equals the height of the blue triangle. So I want to draw your attention to the parts of this equation. So the 100 here, well, that's just this side right there. So let's add it over here to our formula. So the height is this whole equation here. So let's just go ahead and multiply by 100. And then we also have 40 degrees, which is this angle here. So we're going to multiply by sine 40 degrees. Okay, so I've still done 1/2 base times height, but being I didn't have the height, I was able to use sine to find the height. Now, if I were to multiply all this together, I am getting that the area of this triangle is approximately 4,800, and I'm going to round to the nearest whole meter, so 4,821. Okay, that's the area of this triangle. But the purpose of showing you this, the purpose of finding that area, is actually, in fact, to come up with an equation that we can use when we have a non-right triangle, or we don't know what the height is of our triangle. Right? So let's draw a new triangle here. So SAS triangle area formula. So first, let's start by drawing a triangle that we can refer to in our formula. And something you need to know is that when a triangle has a vertex of A, that means the opposite side is called little a. So if this vertex is B, that makes this side B. And if this vertex is C, that makes this side little c. Okay, so what parts do we have to our formula here? We can find the area by doing 1/2 base times the height. But let's see how that relates over here. So I have our base here, and then the height is a matter of using that trig equation that we used before. Now notice it says the side angle side triangle area formula. So what it's saying is if you have a side and an included angle, then you can find the area of that triangle. So we're going to use our triangle here. So if we have the side B and we're given angle C, then we would take B and we would multiply it by, and I'm trying to color code it here for you. Notice that this 100 came from over here, right? So here, that would be side A. So we're going to multiply those together. And then we need sine of the included angle. So in our triangle down here, the included angle is C. So times sine C. Okay, so let me show you how, in this case, we have it in the bottom, the angle is in the bottom right-hand corner. It works for any of the sides in any orientation. It's just that you need to have the included angle. So we could write this a few different ways. This is the same formula, but let's say instead we are given this C side here. So we would have 1/2 C, and if we were also given this B side, so times B, then we would need this angle right here. So sine of A. Okay, so there's one more way to write this formula. It's all the same formula, it just depends on the sides that you're given and the angle that you're given. So we've already done, look at the pattern here. We have A and B being multiplied together. That means that the angle C has to go in here. We have C and B being multiplied together, so big A has to go in here. So pause the video and see if you can come up with the last scenario that we could be given here and come up with the formula. Okay, hopefully you did that. So we have area of 1/2. Okay, so we've done CB, we've done BA. What have we not done yet? Well, we haven't done, I'm going to get this all black again. We have not done CA multiplied together. So let's go ahead and do that. So if we have the side C, then we can take that and we would also have to be given the side A and multiply those together. And then what would go with the sine? What angle is going to go in the sine? With the sine, well, it'd have to be the included angle. All right, so here's our angle that's included between C and A. So sine B. Okay. It's just a matter of taking the two sides, multiplying them together, and then multiplying it by the included angle. That's all there is to doing law of sines and finding the area with law of sines. Okay, so I've given you some basic law of sines area problems here, and I say that they're basic because I'm only giving you the information that you would have to use in your formula, as opposed to giving you all the sides and then you having to decide which sides to use. But for A, let's go ahead. Now we see that we're not given the height. But that's fine because now we know that the law of sines is how we would figure this out. So I want you to go ahead and try these problems, and then I will go over them when you're ready. Okay, so area equals 1/2 A times B times the sine of C. Okay, and you can label all the sides, but really what you need to know is I need two sides, and then I need the angle in between them, and that's what I'm given. So this is perfect. 1/2 times 33 times 29 times the sine of 55. And I am getting the area is approximately 391. And I'm just going to go 2 decimal places. It doesn't tell me where to go, but that's where I'm going to go. All right, try the next one over here. Set it up, find an answer. Okay, so we have area equals, well, I need the two sides and the included angle. There's two sides, and I am given an included angle here. So 1/2 times 21 times 38.5 times the sine of 72. Okay, I am getting 384.46, and let's just go ahead and put some units on here. We are talking about area, so it's centimeters squared. Okay, well, what else can we do with sines when we do not have a right triangle? Okay, so the triangle that we are looking for sides for is this triangle, triangle ABC. Okay, so previously when we're looking for sides or angles, we were always given a right triangle. Now, and you can see down here in this image here, we're going to be given non-right triangles, and we're going to be looking for sides of non-right triangles. Now, the way to find sides of non-right triangles when you're given the right information is using the law of sines is one of the ways. So we're first going to derive, so come up with the formula for law of sines, and then we're going to actually use it. So coming back up to this triangle that I have in red here, if I have this right triangle in here, it is true that sine of B equals opposite, so H, over the hypotenuse A. Okay, it is also true that sine of angle A equals hypotenuse over B. All right, both of those things are true. So now we're just going to use a little bit of algebraic manipulation to derive the law of sines. On my equation over here in turquoise, I'm going to get the H by itself, right? So I'm going to multiply both sides by A. So I have A sine B. Now this is going to help me because notice that H is in both of these equations, right? So I'm going to be able to do some substitution here a little bit. But I have H here. Now I'm going to multiply both sides of the orange equation by B. So I have B times the sine of A equals h. And we have h in here also. So by substitution, right, I could just substitute, I can take out the h and go, okay, well, if h is in both of my equations, then let's take out the h and just make this a times sine b equals b times sine a. So we've been working a lot with proportions and doing cross multiplying, and basically what I'm going to do here, I'm going to get it so I have set up a proportion. So right now it's not a proportion, but if let's divide over here by a, keep the equation balanced. I have to divide both sides by a. So now I have sine of angle b equals b times sine a all over a. Now let's divide by b, right? Or multiply by 1 over b. That's the same as dividing by b. So here these cancel out. And now I have, and I'm going to write it down here because now we have part of law of sines. We have sine b over b equals sine a over a. Now, if I want to come back up to this other triangle here, I could drop a height in here. And I could do the same process with C and with the B again, right? And then I would have sine B over B equals sine C over little c, right? So if it's equal to this one here, then it's equal to this one. So this whole thing is true. I'm not going to go through the process again because we just went through it once, but the whole thing is true where sine C, big C over little c. All of these are true. Now, you're going to end up only using 2 of them at a time to set up a proportion. So you'll either have these 2 or these 2, but it's just you need to know that any of them can be paired up together. So let's go ahead and use this. What are we given in this triangle? Well, we are given A. We're given angle A. And remember, I keep trying to reinforce that inside the parentheses always goes the angle. So I know that this angle 59, which is big A, is going to go inside of some parentheses here. So I have the sine of 59. Now what does that go over? It goes over little a. So it goes over this side right here, the side that's across the triangle from the angle. So I have sine 59, that's going to go over 350, equals, well, I'm looking for b here. I'm looking for little b right there. So little b is going to go on the bottom, because our sides are going on the bottom, and we're just going to leave it as little b. And then with it needs to go an angle. I need sine, and what I need it to be is big B. And we're going to want to put it in here. Put a little mark in there. It's going to want to go in there. So what is big B? Well, we have a measurement for that. The measurement for big B is right here, and it is across the triangle from little b. So let's put in 38 inside of there. All right, now it's just a matter of cross multiplying and solving for little b. So let's go ahead and cross multiply. So I have b times the sine of 59 equals 350 times the sine of 38. These two here are being multiplied together. So let's divide them. Sine of 59. These cancel out. And I put this sine of 59 here. Now, let's work on this in class, but I'd like you to be able to put all of this into your calculator correctly without rounding, so that way at the end when you round, you have the most exact number possible. So go ahead and try that in your calculator right now. And I am coming up with the approximate answer. Let's get rid of that as well. The approximate answer, and it doesn't say where to round to, so I'm just going to pick 251.4. And we have centimeters, so this is centimeters right there. All right, so let's just see if that makes sense real quick. So we have 59, which is across from 350. That means if this angle, 38, is smaller than 59, which it is, right? It's a smaller angle, then this side must be smaller than that side. So at least we're seeing that there, so we can feel fairly confident about our answer. So there we go. We found B in this triangle. Okay, we have two triangles here that we're going to try to find another piece for. I think the first question here is, well, what piece are we going to find? So let's see what we have and see what we can set up here. So I'm seeing that we have angle A, and we also have side little a. And if you want to go ahead and label it with little a, that might be helpful to keep it straight. So I'm going to set up a proportion here where I have sine 36 over 160. All right, I also have a side here. The side I have been given is little b. So that means I can be working with big B and little b. Well, if I look, I do not have an angle for big B. So that's what we're going to find. So sine big B over little b, which is 260. Okay, go ahead and cross multiply and rejoin me when you're ready. Okay, at this point you should have this equation here. Now we need to solve. We're trying to get everything away from b over here. So for starters, I know I'm going to divide by 160 because I have 160 times sine b. So let's divide by 160, which gives me 260 sine 36 over 160 equals sine b. Okay, so think about what we did before when we had a variable inside the parentheses after sine. Well, what did we do to get that variable by itself? We did the inverse, right? So inverse like that. So I'm going to take this and I'm going to do the inverse of everything that's over here. Sine 36 all over 160. Okay, pause the video, type it in your calculator, see if you can get all that in there correctly to get the right answer. And I am getting that B is approximately, we'll round to the nearest whole number here, 73 degrees. Okay, now I want to show you something special that's going on here. I have two triangles. I have the one on the left and the one on the right that actually have the exact same measurements, right? We can get rid of this stuff now. If you look at the sides here, we have 160, we have 160, we have 260, we have 260, and we have 36 and 36. So why am I coming up with 73 when there's two angles here? Now notice one of them is acute and one is obtuse, right? Slightly obtuse, you can barely tell, but it is in fact obtuse. All right, so there is a way to find both angles, but this year in this class, we're only going to focus on finding the acute angle. But I want you to remember that the reason we have two angles here is, do you guys recall when we were talking about triangle congruence, that side-side angle, right, does not prove triangles congruent. So if you have side-side angle, they're not necessarily congruent because you could have two different situations. And here's an example of this two different situations. You can have it with an acute angle, or it could flip in like this, right, and have an obtuse angle. If I were to draw that triangle over here, or on the left, onto this triangle, that's where that side is, right? It can be 160, whether it's here or whether it's there. It is this portion of the triangle that is getting shorter or longer depending on whether that angle is obtuse or acute. So the main thing you have to pull from here is that when we find angles using law of sines, we're going to find acute angles only. Okay. We're going to find acute angles only, and the other thing you need to know is another angle exists, right? If you're given side-side angle, it's possible to have two types of angles, but for this year, we're just going to focus on those acute angles. All right, so give these problems a try, and then watch me solve them when you're done. This is the proportion that you should have set up there, and it's telling us to find AB, but it's also the only side we can find right now with law of sines because the information we have is big C and little c and big B and little b. Okay, on this step, all I did was cross multiply, so I have 7 times sine 53 and c times sine 44. And then the last part of solving this equation before I put it into my calculator is to take sine 44 and divide both sides. It would cancel out on the right, and we're left with what we have on the left there. So just type that into your calculator. And we get our side C is approximately 8.05. And we don't have any units on this. So AB is 8.05. Let's just double check, does that make sense? Well, 44 is across from 7, so 53 is a bigger angle. We should have a slightly bigger side, which we do. 8 is bigger than 7. All right, go ahead and set up this next one and try to solve it, and then rejoin me when you're ready. Okay, this is the proportion you should have set up. Now, keep in mind, this is one of those examples where we are given a side angle, side angle. So we can see that it is an acute angle. But there could be a triangle that looks like that instead, with the same exact measurements, with this 250 and that 150. And then we would need to find the obtuse angle in a different way. But for now, let's just work on trying to find that acute angle. Okay, go ahead and cross multiply. We have 150 times the sine of 69 and 250 times the sine b. The next step would be to divide by 250. And then how are we going to get that b by itself? Well, remember, that's just inverse. So the inverse of sine, and we're just going to put all of this inside of there. And that will give us b. Okay, and if you're struggling with getting the right answer in your calculator, don't worry about it. We will look at that in class, but just try your best in this video. And I am coming up with an approximate angle of 34 degrees. All right, thanks for watching, and I will see you in class.